Welcome to this Mobile World Live webinar, Edge Compute, coming to a place near you. I'm Martha DeGrasse, here for GSMA, and I'm delighted to be welcomed by Krister Boberg. He is Head of Technology and Strategy at Ericsson's Global Network Platform. Ericsson, Krister, thank you so much for being here.
Thank you, Martha.
Roger Berg is also here. He is VP for North American Research at Denso International America. Welcome, Roger.
Hello, Martha. Hello, everyone. Pleasure to be here.
And we have Tim Hatt, Head of Research and Consulting at GSMA. Hi, Tim.
Hi, Martha. Great to be here.
Yeah, it's going to be a really good webinar. So Krister and Roger are both part of the Automotive Edge Computing Consortium, and Krister is going to kick us off with a little bit of an overview of the consortium.
Thank you, Martha. So yes, if you move to the next slide, please, and even the next one. So AECC, Automotive Edge Computing Consortium, is something we started back in 2018 to look at how can we bring the networks and the compute infrastructures to support what we at that time point in time called the big data for automotive. If we look at the projections from the automotive industry, and not the least from Toyota being part of AECC, we will see that the amount of data coming from the cars to the cars from the network and vice versa can be huge if we have the right conditions. However, at current and back then and even currently, we don't see that those networks are really managing these data volumes. Please go to the next one. So with the amount of cars, with the amount of value that we see and how much the car industry can bring, we think it's a huge opportunity for all actors in this area to take this very seriously and make this infrastructure available for the automotive industry. Please move to the next one. And next one again. So the mission we have is that from AECC point of view, we work with all the leaders or the main leaders across industries, not only the automotive industry, but the providers of the functionality to make this evolution of the network architecture and the computing infrastructure. And the plan is here to unlock what they call the AI-driven capabilities to deliver smarter, more efficient connected vehicle services. Next, please. And on high level, there are two main things we talk about. One is how do we filter the data at an early stage to manage the data at an edge instead of sending it to a central cloud. And also how to steer what data we actually send and receive from the car at as early as possible, instead of transporting all this data from the car to central location. Manage the data as early as possible, or at the place where it makes sense to process the data. Please move to the next one. And this is something we do specifically by dividing the data structures into what we call localized networks and using distributed computing to do that. And that is part of what we define in AECC and our technical reports. Please move to the next one. And the AECC today is a quite small but very effective team working on these particular topics. Together in between automakers, tier ones, mobile operators, telco vendors, compute infrastructure providers. And this is the main activities we do, and we are continuing that with what we call our proof of concept program that I would like Roger to talk a little bit about.
Thank you, Krister. You can see from the names on this slide, there's some quite powerful players in the industry, but that doesn't mean that those players are over dominant in our consortium. it's really nice to have a group of collaborative partners, I would call them partners, in our organization that allow everyone to say what they think are the right things to say, or promote their ideas. And so I think it's a wonderful collaborative community. And it helps when we start to talk about the proof of concept program, which is really heavily emphasized by the AECC. If I can see the next slide, please. And we'll move one more, please. So our proof of concept really takes the concepts or the ideas that we have through our defining our use cases, and also using those use cases and those requirements to create architectures or implementations of a network communications and computing fabric, I'll call it, to actually execute some of these use cases and demonstrate that the requirements are sound and that their technologies exist to enable those execution of those requirements. So these are really visible, tangible outcomes that our organization emphasizes as proof of the pie or proof of the pudding, that says what we have proposed as use cases and what we have proposed as solutions to executing those fundamental objectives are sound in the wild. So these are implementations we might use in the field. I'll give an example later, or simulations that we can depend on to show that our solutions are viable and usable in the real world in a commercial deployment sense. The beauty is you don't even have to be a member to participate. You don't have to be a member of AECC to participate in our proof of concept program. You do need a sponsor from a member company, but you don't need to necessarily be a member. We hope through your experience in contributing to these proof of concept operations, we have I think over a half a dozen of them now out and available for your observation through our website. Through your experience with these proof of concepts and showing that our ideas are viable, we invite you to join and contribute at a larger scale, all the way from proof of concepts, not proof of concepts, all the way from use cases through data architecture implementations. And if your company has some idea on some special feature, we can work that through into a proof of concept. Can I look at the next slide, please? One example of this kind of idea of proof of concept that went through the whole cycle of use case, architecture, description, and implementation is this one where we use, in essence, crowdsourcing of visual images to identify parking places, parking spots. For those of you who are familiar with trying to look for an empty parking spot in a large urban area, you understand sometimes you drive around for 30 minutes, 45 minutes, an hour looking for an available parking spot, and you circle around your intended destination and you can't find a spot. What this proof of concept demonstrated was that we used edge computing, computation, and data storage in two different regions in Japan to show that we can use crowdsourced images to indicate the location of empty parking spots. So if you signed up for such a service, you wouldn't need to necessarily drive around for 30, 40, 60 minutes looking for a parking spot, because one would be advised for you. This imaging can geolocate where this parking spot is and advise you that there's one open and you should go as fast as you can. So this is a demonstrable result that showed our use case, our architecture for implementation, and the actuality of demonstrating this in the real world. This was in 2 different cities, in Tokyo and Osaka, I believe, in Japan, that this concept and architecture really works. I see the next slide. So, like I mentioned, if you're interested in participating in an example like that, or any other kind of use case you might have as an interested party, talk to one of the members that you saw on the screen, or we'll give you some contact information. I think it's on the next slide, if I can see that. Or yeah, here's where you can see the proof of concepts we've done already, and maybe this will inspire you to think of a new thing that you would like to show the benefits of edge computing, communications, and data storage in a time and space coincident manner to help us demonstrate that our ideas are commercializable and realizable in the real world.
Thank you so much, Roger.
Thank you, Martha, and thank you, Krista.
All right, Tim is going to share some research with us now that is specific to edge compute. Tim?
Thank you very much, Martha. So, yes, if we can move to the next slide here. So, thanks very much. So, hi, everybody. Tim Hatt here. I am part of the GSMA Intelligence team, which is the analyst arm of the GSMA. And we're really excited about this research that Roger and Krista were just referring to, and that we released earlier on in the year, because I think it's an interesting time for edge compute, both from a demand perspective, as well as looking at a sort of set of use cases that have evolved quite a lot, to be honest, since we were talking about edge 4 or 5 years ago. The reports have been published. I'm just going to spend about 10 minutes now going through some of what we think are the sort of main highlights to set the table for the panel discussion we'll have after to deep dive on some of the topics. So if we can move to the next slide. This is a bit about us. You can find that out. As I just said, we're the research and consulting arm and have a remit across telecoms and broader TMT. Next slide, please. I think it's a good context slide to sort of paint the view of where we're at in the 5G evolution, because that's a key sort of component to how we talk about edge in general. This is showing our projections, of 5G compared to previous generations of mobility. And you can actually see here that 5G is the fastest take-up path of any generation of mobility that we've seen. We're at about 20% global adoption now. If you look at pound for pound compared to 4G LTE, it's achieved that, adoption rate almost twice as fast. So launched in 2019, and here we are 5 years later, and we're at that level of take-up. Now, the interesting thing is that I think this speaks to a lot of the new monetization opportunities we see, particularly in the enterprise side, where that's probably the largest source of incremental revenue for telco operators and their partners, of which edge compute is a big part. So I think that's an important piece of context. If we can go to the next slide. The other thing that's important, and I'll talk about how sort of various technologies link in a minute, but the other sort of important bit of industry context is around IoT. Now, what we're showing here is our team's projections for IoT devices and connections globally out to the end of the decade. And so you can see that, the forecast horizon, we get it to just under 40 billion, about 38 billion to be exact. But the key point here is not so much the total number, it's the enterprises driving the growth. It'll account for about 2/3 of that base by the end of the decade, but that it's also expanding into a number of new vertical sectors, from manufacturing to transit hubs, to healthcare, to automotive, as Roger was referring to, and that puts a lot of more compute power and capability close to the edge and close to where that power is going to be used. So as the range of IoT devices grows and the volume grows, so too does the opportunity for laying the edge infrastructure to help unite that. So if we can go to the next slide. I talked about, how different technologies link or coalesce. This is a visual we included in the published report to show, how, edge links with other infrastructure and software layers that ultimately amount to kind of go-to-market solutions. And I think, the big change that we've seen from when we talked about edge, as I say, sort of 5 years ago, is that obviously you have 5G capabilities in place. That helps latency. That's a very key part of servicing things like connected cars, V2X, other sort of ultra low latency applications. That's in place. But then even more recently, now the advent of machine learning and increasingly Gen AI. And I think where things go, and it's interesting from a technology perspective, is that you start to see these things integrated in a single stack, where you still have apps and software at the top of that, but where there's intelligence infused up and down that stack to really make edge compute more impactful from a business perspective. Because ultimately what IT buyers and others want from edge compute is the ability to make sense of that data and help their business processes and ROI. So if we can go to the next slide. When we look at the range of industries that have or are interested in deploying edge compute infrastructure, there's a lot. I show this slide here around the car making sector because historically that's been sort of one of the foundations for edge compute deployment. And to a large extent, it still is well reflected. We ran a survey to support this, our reports. We actually covered 5 different industries, of which automotive is one. And you can see in this chart that there's still a number of services that car makers are deploying that leverage edge compute, whether that's mapping, infotainment, and mobility as a service, cruise assist, and then of course the long discussed, still prospectful notion of autonomous vehicles. I think this picture has evolved over time. We're now looking at deeper integration of the infrastructure and increasingly that low latency, but this still remains a foundation sector for where edge gets deployed. But equally, and if we can go to the next slide, I think one of the sort of real points of interest from the survey we ran was that if you ask sort of companies that sit in the edge value chain where they thought the greatest demand lay, you actually get a sort of set of new kids on the block and a variety of participants here. And this chart here is a sort of graphical representation of that. So you can see electronics and consumer electronics manufacturing at the top, media and broadcast, retail. I talked about transportation, which is actually a higher category if you include things like airports and train stations and aggregated into one. And what this says to us is that the range of potential deployment sectors and investors for edge capabilities has expanded quite a lot out from beyond just the automotive industry. And so that was the sort of key hypothesis that we made and that's been validated through this. The question now is how best to harmonize 5G infrastructure with AI and edge to be able to service demand from these verticals. If we can go to the next slide. It's always an important question to ask what the economic indicators are for infrastructure investment. We do that for telecoms in general. We've done it for edge infrastructure solutions here specifically. So what this is showing here is that we asked our survey participants, which was global, whether they, how much their anticipation was around investment sentiments for 2024. We ran the survey in the summer of last year, and so this was looking ahead to the current year. And you can see sort of the broad base of investors expect an increase in their spend on edge compute. Some more, some less. There is some who anticipate downgrading spend, but by and large, reflections are upward. And actually, we get to a median spend rise of about 10 to 15% from this sentiment indicator. Now, that, of course, is a survey. It's one proxy, but it's a useful one given that we've canvassed so many sectors. I think what's interesting about this is that it reflects both that broad-based demand that I just talked to on the previous slide. It also probably further builds on the economic recovery from the pandemic, some of the COVID era constraints on capital investment starting to wind down. Of course, the economy still has challenges, but we're seeing that there is more of a case here to make these investments. The key comes into demonstrating the ROI over time. And that's something we really want to talk about, I think, in the panel and monitor closely in the sector. So if we can go to the next slide, which I think is the last slide. This is really a corollary to the previous point I made around investment. And this is the other side of the coin about who actually should shoulder the burden for the infrastructure investment, given that it's a very diffuse value chain, as it were. And so one of the points I think that's coming out of this is if you ask people, well, who are the main capital providers for edge infrastructure between telco operators, network vendors, data center providers, cloud providers, car manufacturers, et cetera, most people still rank the operators as the number one provider there. And so you see that 43% with that ticked rectangle around it, that is seen as operators investing the most. And indeed, interestingly, if you look on the bottom chart, most operators rate themselves as being the predominant investor. The challenge with this is that that's not sustainable over time. We're still in a reasonably subdued revenue growth environment, while, of course, 5G new radio investments are being made, especially in standalone networks. And so one of the points we wanted to really make in this report is that there's a need for flexibility in the funding models for how edge infrastructure is deployed, more innovation in how that funding works, and potentially new models altogether. And I think you'll see some interesting case studies if you look in the report. But I think where we see that latent spend gap is perhaps among participants in other parts of the value chain, where if we can get that ROI clarity in place, I think that would release some of that funding and convert it from latent to actual, and we would have a more equitable distribution and something that's probably more sustainable in the long term. So the last slide is just a QR code to reiterate that you can come and download the reports. There are two of them. There's a long form report and there is more of a summary findings deck. Very much appreciate you to come and have a look at those, and we're always open to get in touch with questions on. But with that, Martha, I will hand back to you for the discussion.
Thank you very much, Tim. So we do have some audience questions coming in around, not surprisingly, AI. So we're going to start there. What is the role of AI workloads on the edge, and how does cloud AI connect to AI on tiny edge devices? Krister, do you want to start with that one?
Okay. the tiny edge device, I think when we look at edge here, specifically on the automotive side, we talk about typically different type of edges. One is the edge, which is device near or in the device, where the MCUs, I would say, typically resides. And then we have what we call sometimes depending on from what side we look at, the cloud near edge or the access near edge, where maybe the MCU type of setup is not necessarily required in that sense. So the things, what we look at from an AECC perspective, starting with the main use cases, are specifically looking at what I call the cloud near edge, meaning that we handle, so to say, processing of data close to the access point, and filtering that data, managing that data, typically with an AI-based model before we decide what to do with the data, sending it to the cloud, or managing that before you send back instructions to the car, or managing it in other ways. So that is the main part we discuss with AI and edge here. So on high level, Roger, maybe you have some more insights on the device side here from the car side.
Yeah, I don't know if I have any more insights than you do, Krister, but I think I can dovetail on some of what you mentioned, that there is an increased amount of processing and AI / machine learning near or at the edge, even in the devices. And some of the research that we're doing through my company and within AECC as well has to do with the idea of federated learning, and not necessarily transferring all of the raw data to a cloud or even to a processing edge, but developing models at the individual device level, and exchanging information on what those models might look like, those machine learning models, instead of transferring huge amounts of video data or LiDAR data, in the case of automotive, LiDAR data or radar data. So I think we're seeing that the distribution of processing power and the need for different communications and different data storage areas across the whole stack or across the network, in some applications necessitating that processing being done in the edge device. In some, it's in the next layer up, like the network edge, I think is called in the report. And then there's also some like generative AI, those large language models that need to necessarily be done in the cloud. So I think there's room for different processing levels and different layers in that architecture, depending on the needs of the application at the end.
So is the amount of processing that needs to be done the reason that some data would have to go to the cloud? We have a question here from the audience. Why is there not more AI decision and algorithm building on the edge? With data privacy and AI regulation coming on, should we not reduce our appetite for centralizing data to the cloud? Is that just a function of the edge is not robust enough for some all use cases, or what's the reason there?
In my opinion, it's not robust enough for all use cases. The list of applicable use cases is growing with the advent of some SoC technology and the idea of the software processing data from different heterogeneous sources. So that's getting better as we progress, and some of this investment that Tim's talking about continues all up and down that distribution chain, I'll call it, within the network equipment and the devices themselves.
Okay, good. Okay, I think we should spend a little bit of time on 5G standalone. Tim mentioned it as an investment priority for the operators, but it would be good to just touch on how the combination of 5GSA and edge processing can open up new capabilities for connected vehicles. Roger, do you want to take that first?
Sure, I'm talking too much, but sure. So the idea of the standalone network, and maybe Krister can expand on this, but the idea of slotting prioritization in the network access and the availability of resources within the computing and communication fabric, as I mentioned before, that flexibility offers a lot more, a wider open field in terms of what can be done and what's commercially viable to do within the computing communications network. 5G offers all of us better latency, much better latency, much better even bandwidth. So when we do need to transfer these large critical timing information in order to process, that conduit, that pipeline is available. And with expanded computation available and the way the software can configure or software can define the network operation parameters, that flexibility gives us all, like I mentioned, a wider open field to play in, so to speak. And I think that brings in a number of different vertical markets that now can see the value of having a network capability and capacity like that to just expand the number of use cases possible.
So with these new opportunities, do you think the automotive industry will become more willing to invest in 5G connectivity for vehicles?
I believe so. The preponderance of the use cases we have tried to address so far kind of limit themselves because of the accessibility and the uniformity of feature sets across networks and across regions. I think from an automotive perspective, and I've talked about this in the past, you can't have a feature that works in South Carolina that doesn't work in Colorado, or one that works in London that doesn't work in Berlin, or one that works in Tokyo that doesn't work in Osaka. So that uniformity of availability on features and capabilities for the compute and communication network is of paramount importance to the uniformity of user experience when it comes to the automotive use of edge computing.
Yeah, and that gets into real-time roaming, I think, between networks, right? I think, Krister, you've done some work there too, right?
Yeah, just to comment a bit on the previous one, I think that just to emphasize a bit on what Roger talked about here, that I mean, if we talk about 5G, everyone knows that it's about higher bandwidth, lower latency, and what you call differentiated connectivity. But you cannot really differentiate unless it's what we call end-to-end. So that's why the 5G and the edge have it's a great combination. You actually need it to provide the full feature set that you need. And I think also to the second point that there are obviously a big interest in 5G from the automotive industry, but the lack of coverage until now, and the if you say so, the limited value perceived value compared to earlier generations will have sort of limited the interest, but that is required in order to actually build the new services, as we talk about in AECC. So the combination there is required, just so we are clear on that. For the roaming case, I think this also relates very much to the work we have been doing in AECC, because we are talking about big data or the high volume data of the automotive industry, and the roaming model was created for initially for traveling across countries. So the permanent roaming model, where you actually have not the local access, is not really appropriate for that, because you have to send the data all over the network, trombone the data, as we call it. So we typically talk about using local access and technologies such as eSIM to move to the local network, so you can have a local breakout for the data. And actually, in that sense, the local breakout with the user plane of the 5G network in combination with the edge, you can do your AI workloads as close as possible to the vehicle, instead of having to send it back to the other network. So that is also something that we will accelerate work on in AECC during spring and early summer here, related to the eSIM and technology, and how that is applicable for the automotive industry.
Excellent. And what about non-terrestrial networks? Do they have a role to play in roaming? Yeah.
In roaming, well, NTN networks, I think NTN networks will be there. I think if we talk about edge compute and NTN, it's interesting, because of course the reason you have a satellite is that you want coverage. But the problem, if I put it like that, with edge compute in NTNs, is that you also need to go to the NTN gateway in order to have the closest edge, and then maybe you even have to go to the 5G SA network or 5G network, and then you have the edge at that point. So yeah, that is NTN and automotive is probably required in cases where you don't have full coverage. But it's obviously when it comes to some of these services that require low latency, maybe not necessarily applicable to that. So,
Roger, do you have anything to add here before we move on?
Not so much. I think Krister covered most of it. We in the automotive industry are interested in non-terrestrial networks because of that coverage problem that I had mentioned before. But as Krister mentioned, it may not offer the low latency of some of the application sets that we necessitate.
Well,
I think it's more, just to quickly build on that, I think
Sure.
it's more, we are definitely seeing an expanded coverage set driven by NTN integration with both 4G and now 5G networks, but that's still servicing mostly low bandwidth applications, text and potentially some voice calls. And it's more likely to be a tactical infill solution that seamlessly hands over to cellular signals that handle most of the edge processing. So it's a part of the solution, but it wouldn't be there on its own.
All right. We have an audience question. An audience member wants to know if you all see any use cases where data doesn't need to be real time and requires the data to be cached at different points in the network, or even in the car itself.
Yeah, so I touched on that a little bit when we talked about federated learning.
Yeah.
The idea of some of the government data policies or legislation across the world, not just in Europe, but also in the US, at the state and even federal level, necessitates some of that storage not in the cloud or not in a regional data storage facility. So we're seeing some of the, instead of the raw data, like I mentioned before, raw data being sent and processed in edge or cloud, or not edge, network edge or cloud. A lot more of that is being considered to necessitate processing at the individual agent level. And instead of transferring that sometimes private data about where some sensor was at some certain period of time is considered private information that can't be stored in some of those locations. So we're looking at processing that kind of thing from a AI and machine learning perspective, actually at the device level, and sharing knowledge based on AI models instead of on raw sensor data.
Okay, so at the vehicle level, right?
Mm-hmm.
Okay, anybody else have anything to add on this before we move on?
Yeah, maybe just to say that, as Roger talked about before as well, that and the AECC is very much about high volume and not necessarily low latency data, right? So absolutely, this relaxed requirements on latency is something we are specifically looking at. And we even talk about things like background data transfer. How can data be sent when there's less congestion in the networks, etc., to offload offload networks, etc. So that is part of the work we do, for sure.
Okay. Tim touched a little bit on the investment environment for operators, but I think it would be good to see if you all have any ideas about verticals or players that actually might be willing to make the investment in more edge resources needed to support some of the use cases that have been highlighted. HD mapping. We haven't talked too much about mobility as a service, but I know that has come out in the research as a very promising use case. So are there any ideas here about industries that may be wanting to invest in some of the edge resources needed to support these?
I mean, I can kick off there just to sort of build on the remarks I made in the presentation. I think when you look at so the broad brush is that people from a variety of industries are increasingly seeing the value of situating compute power closer to their premises or on the device, and you're starting to see that I talked about the media and broadcast industry. You're seeing it in retail. You're seeing it in food and beverage. In addition to what we have, the automotive scenarios that we've talked about. I think the questions are less about the provability of the technology and more linking that to ROI. And to the extent that can be case studies and proof points can be done to illuminate that, that's a good thing. And I think that co-investment model also speaks to that sort of desire there. But it is a broad-based sector demand, and certainly from the mobile operators we talk to, that's reflected in those conversations. Of course, it will range depending on the region and country you talk about, but it is a broadening range of demand.
Okay, thank you, Tim. I'd like to stay with you for a minute because I know you're familiar with the GSMA Open Gateway project. This helps developers and cloud providers deploy services across operator networks. Can you share any information about implications that this has for AECC?
Well, the big thing with Open Gateway, and Krister can probably chime in after Roger, is that it provides a new, not only the common standards on the API, which breaks down fragmentations and increases the scale for developers, but it brings a new route to market for monetizing 5G and edge infrastructure. So we're starting to see activity from a number of developers, both solo and affiliated with some of the hyperscalers and other edge providers, in a whole range of industries, as I talked about before. I mean, I think this will be a key year, 2024, for implementing that on the ground and proving the commercial scale of it. But the federated model is built, and now it's a question of, again, coming back to the use cases, the provability on the ROI.
Very nice.
But Krister, do you want to speak to the automotive angle there?
I think, GSMA Open Gateway and the Linux Foundation Camara, as you say, is a big movement, I would say, among the CSPs now to try to see how can we better expose the network assets that we have for the industry. And it started 2 years ago, basically with the Camara work. The GSMA Open Gateway launched last year. And at this year's Mobile World Congress, we saw a huge uptake on the interest of the APIs. I think it's a way for the mobile operators to make their networks more standardized and available to the industry. I think that is the key. Then we will see how it evolves. And we, of course, from AECC perspective, will start to look at this again during spring here. We have an MOU now between AECC and Camara, and we will look at what are the requirements from automotive industry towards the mobile network from an API perspective. So, yeah.
Okay, great. Roger, do you have anything here, or is there anything else that anybody wants to comment about with respect to network APIs?
Yeah, just one comment. I think part of the reason that there was a slow uptake in investment in edge computing, mobile edge computing, was that there were no standards, or there were many different standards. And so the idea that an operator would invest hundreds of millions or billions of dollars in some cases in some infrastructure or some architecture or some capability that would become obsolete in 6 months or a year because something else became the global standard, I think offers a little bit of resiliency in the investment that operators or network equipment providers, as Tim mentioned, need to provide the investment they need to provide. So if we can agree upon methodologies or architectures or the interface, like the open interface and APIs, then I think that will garner a lot more investment and a lot more growth in what kinds of use cases this infrastructure and this investment can provide.
Excellent. Well, that is a good place to wrap it up. But before we do that, I'd like to let everyone know that if you submitted a question and the panelists were not able to answer it, it will be forwarded to them, so you may hear from them. And I'd also like to go back to each of our panelists one last time in case they have any closing comments, and just to thank them. Christer Boberg, Head of Technology and Strategy for Ericsson's Global Network Platform. This has been great. Thank you so much for all your insights.
Thank you. I think this was a great session for us to share some information on what we do in AECC and our mission and how we want to proceed during 2024. I think the things related to how do we combine the 5G network with the edge, and how do we utilize the network APIs now to expose these assets, both from edge perspective, but also what we call about differentiated connectivity, will be keys for us. We are happy to see others joining into this mission we have during 2024. Thank you.
Yeah, it definitely seems like there's some traction. Okay, great. Roger Berg, VP for North American R&D for Denso International America.
Yeah, I think I'd like to agree with a lot with what Christer talked about. In the AECC, we're kind of seeing a rejuvenation of edge computing and the excitement and the commercializability of edge computing that we talked about for 5 years or longer. We're finally seeing it come to fruition. Our proof of concept program or project allows us to demonstrate real tangible outcomes and shows that the work that we've done, the theoretical work that we've done, and the use case processing and solving some of these highly technical issues is doable and is commercializable and is at the precipice of really becoming useful in the social marketplace in the network that our customers work and live.
In the real world, absolutely.
Exciting, yeah, it's real exciting.
It is. All right, and Tim Hatt, Head of Research and Consulting for GSMA.
Yeah, thank you again, for having me. And I think, I just echo what Krista and Roger said. I mean, for us, this is a key year of watching edge implementations, especially with the integration of AI and Gen AI. And I think, to Roger's point, the more we can see the proof of concepts coming through with disclosure and then transitioning to commercial implementations, that will tell a lot about the impact of these deployments across what is a broadening sector demand across different industries.
Definitely. All right. Thank you all so much. This has been a great webinar. I'm Martha DeGrasse here from Mobile World Live, and this will conclude our presentation for today.